Okay, this is Algebra 2. This is lesson 4-7 on page 134. And this is using factoring to solve equations. And this is why we went through the last couple of lessons to really nail down factoring. Hopefully we did. Because using factoring to solve equations turns out to be a really valuable tool. Okay, it can be a wonderful way to do that. So what I actually want to do is I want to go straight to the exercises on page 136 and just walk through the process of how we do this, solving equations by factoring. Okay, so we're just going to start with number 2, and you may already be familiar with this process from previous algebra. But number 2 says x squared minus 9x plus 8 equals 0. Okay? Now, when we are solving equations by factoring, the first thing that we need to do is make sure our equation is set equal to 0. Sometimes we have to manipulate the equation to do that, and I'll jump to an example to show how that's done, a different problem where we can show how that manipulation is done. All right, but when you look at the written exercises on page 136, you'll see that numbers 1 through 10, they're all equations set equal to 0, right? So our goal in being able to solve by factoring is to set our equation equal to 0. That's rule number 1. Now we want to factor, and these problems are, I would think, for the most part, will be contrived, so you can expect that you'll be able to factor the trinomial into a binomial. All right, so let's just think about our process, right? X squared, how do we get that? Well, that's just x times x, right? I look here and I see that the constant term is positive, and so that means that the signs in the binomials need to be the same. Since they need to be the same, they will be whatever the sign is here on the linear term, and so they're both going to be negative. Right, so now I need to think about two numbers that multiplied together equal 8, and that I can combine and make a 9. Right, so 4 times 2, there's no way you can combine a 4 and a 2 and get a 9. But you can combine an 8 and a 1. And so I would say we have x minus 8 and x minus 1 as our two factors. Okay, now let's think about this, what this means. If you have two numbers that you multiply together that equals 0, at least one of those numbers has to be 0, right? The only way you get a 0 when you multiply is if you multiply by 0, right? Now, 0 times 0 is 0, so it's possible that both could be 0. It doesn't, I mean, when I look at that, intuitively, I don't think that both would be 0 at the same time here, since it's x minus 8 and x minus 1, right? But, anyhow, one of these at least has to be 0. So if one at least has to be 0, what we can do is take each one separately and set them equal to 0, because there is a scenario. In order for x squared minus 9x plus 8 to equal 0, x minus 8 could equal 0, or x minus 1 could equal 0. Right? Well, let's solve this for x. Clearly x equals 8 here, x equals 1 here, and there's my solution set. X equals 8 or x equals 1. Those are the two possible solutions for number 2. Okay? Now, let's jump down to number 12 as an example. And it says 4y equals 6y squared. Okay? Well, remember, our first rule here when we want to solve by factoring is to set the equation equal to 0. If I subtract 4y from each side, I would have 0 equals 6y squared minus 4y, right? If I'm not comfortable with the way it looks, I mean, the great thing about an equal sign is that the two things on each side are equal, and so we can just flip it around if I'm more comfortable with it, writing it this way. 6y squared minus 4y equals 0, okay? You know, just do what is comfortable for you, right? Okay, now let's think about the 6y squared minus 4y. I see I could factor a 2y out. And that would be times the factor 3y minus 2. Okay, so this one's a little bit different. We didn't end up with a binomial. We ended up with this 2y term and then the factor 3y minus 2. But it's still the same thing. We have two factors here. We have 2y times the factor 3y minus 2. So we can set each of these equal to 0. The 2y equal to 0. The 3y minus 2 equal to 0. Well, obviously over here, this would just be y equals 0, right? I mean, the only way you can get 0 if you're multiplying 2 to a number is to multiply it to 0, right? Now over here, and that's an equal sign, not a less than there, we get 3y equals 2. Now we're going to divide each side by 3, so y equals 2/3. And so y either equals 0 or y equals 2/3. That's the solution set to this original equation. Okay? And that's how we handle these types of problems. Okay? So remember, we're always trying to set them, set the equation equal to 0, and then we can take the factors and set each factor equal to 0. Okay? All right, so your assignment here is to do numbers 1 through 25 odd on page 136.